Cisco Certified Network Associate Day 43. Welcome back everyone, I'm Imran, your trainer for this entire series. Today we're going to talk about distance vector versus link state, and this video is going to act like a precursor to our most sought after video, which is OSPF and EIGRP. So we will be starting OSPF and EIGRP. So next maybe about 4 or 6 videos are going to be the most important of your entire Ccna journey with us, right? So they are going to be the most critical videos, the next 4 videos, or maybe I might stretch it to 6 videos, right? We'll cover OSPF and EIGRP, and today it's going to be a very brief video. We would just look at few concepts that you need to know before we start into OSPF and EIGRP, right? So without wasting much time, let's get straight into today's class. And like always, before we get into a video, I would request you to click on that subscribe button and click on that bell icon to be notified when we add a new video. And also don't forget to click on that like button, which would make us very happy. Our social media contacts are on this page. On the left you have our company contacts, on the right you have my personal contacts, and my email address is imran.rafai@nwking.org. So if you have any query with regard to this course or anything in particular regarding your career or IT, please feel free to write to me and I will try and answer all your queries. What are we going to look at in this video? So we would, in our last video we looked at 2.1. So in this video we would be looking at 2.2, which is compare and contrast distance vector and link state routing protocols. And also we will look at 2.3, which is compare and contrast interior and exterior routing protocol. So these are the 2 things we would look into in this video, and I think that is going to be a precursor to our next maybe 6 videos. Like I said, that is going to be our core. It's going to be OSPF version 2, version 3, EIGRP for IPv4 and EIGRP for IPv6, and this is going to be the core, and it's one of the most requested topic in our entire series here. So without wasting much time, let's get into today's video. So 2 important topics that I want you to understand, and this is interview questions. I've had a lot of my students come and ask me this question because this has been asked by interviews. Whenever they go for an interview, they've asked them what is routing protocol and what's the difference between routing protocol and router protocol or routable protocol. So the difference between routing protocol and router protocol. So routing protocol is a protocol used by routers. So we looked at RIP in our ICND1 video, and RIP is a routing protocol. So other routing protocols are EIGRP and OSPF, ISIS, BGP, whatever, right? These are all routing protocols. So basically what a routing protocol does is it's a way routers talk to each other, right? Routers talk to each other and make, like, they exchange network information. So they exchange network information, and the ultimate objective is to fill the routing table. So routing table filling by both the devices, right? So this is what routing protocol is. Routing protocol, they exchange route information that they have connected to them or that they learn from some other source. So they share with each others, and ultimate objective is to fill the routing table. And once you have the routing table, they know how to make routing decisions. So that's what a routing protocol is. A routable or routed protocol is, once the router makes the decision to fill the routing table, it needs to send that traffic. So if there's some traffic that needs to be sent to that particular network, right? They use routed or routable protocols like IPv4, like for instance IPv4, IPv6, right? These are routed protocol or routable protocol. So routed protocol or routable protocols are used to send traffic, right? So routing protocol is used to fill the routing table. Routed protocol or routable protocol like IPv4 and IPv6 are used to send traffic. So data is encapsulated in IP headers, right? So IP is the protocol that is used. So they encapsulate data, they break that data into IP packets, and then they send. So IP protocol, right? IPv4, IPv6 is used by the routers to send traffic. So the difference between routing protocol and routed or routable protocol is this. The next difference is the discussion that we need to have is interior gateway protocol and exterior gateway protocol. Now, interior gateway, now they say gateway here, so don't get confused by gateway. Basically, what they're trying to say is any routing protocol used within an autonomous system, right? Autonomous system, let's say for instance, if it's your company, right? Your company, you have, let's say, 50 routers. So this, whatever routing protocol that you use within your company, right? This is one autonomous system. Autonomous system is something that you call, which is managed by one company or one organization, right? So this is autonomous system. So whatever routing protocol that you use within your company or autonomous system, that is why it's called interior. So everything that is used within an autonomous system is called interior gateway protocol, and the protocol that is used to communicate between two different autonomous systems, that is called exterior, right? So this is interior, and the ones that is used outside the autonomous system is called an exterior routing protocol. So basically, this autonomous system also could be your ISP, right? Your ISP would have maybe 200 devices, 200 routers within that. So that is one autonomous system, and what is used in between is an autonomous system. So what are interior gateway protocols? Protocols like we discussed, RIP, OSPF, EIGRP, right? These are interior gateway protocols. Now, exterior gateway protocol, today the only exterior gateway protocol that's in use is called as BGP, border gateway protocol, right? So this is a protocol that is used exterior. So exterior gateway protocols are protocols used to connect to autonomous system, right? So that is the difference between interior gateway protocol and exterior gateway protocol. The next two terms that you need to understand is distance vector and link state, right? So these are the two types of routing protocols. So interior gateway protocols, there are two types of interior gateway protocols. One is distance vector, right? Distance vector, and the other is called link state. So let's say for instance, we have three routers, right? We have three routers and they're connected with each other. So let's assume there is one network, 192.168.10.0/24 network. Now let's call this A, router B, and router C. Now in RIP, we did RIP in ICMD1. We know that if RIP is enabled, router B, because router B is connected to 192.168.10.0, router B would advertise this network on this link to router A, and also it would advertise the same network to router C. Now router C would in turn advertise that to router A. So from router A's perspective, let's assume this is F0/0 and this F0/1, right? So from A's perspective, from router A's perspective, it is learning this network 192.168.10.0 from B and from C. If you're using RIP, because RIP makes use of a metric called as hop count, it would take this, because it's saying I have access to this network with one hop, and B tells C that it has access to this network with one hop. C tells A that it has access to the same network from two hops. So from A's perspective, from F0/0, it's getting a one hop distance to this network, and via router C, it is getting a two hop distance to this router. So obviously A, because it is using RIP, and RIP is a distance vector routing protocol, it decides on router B. So with the information that we have on the screen, you say that's the right decision to do because that's the shortest distance. But what if I told you this is a 64 kbps line, whereas this is, let's say, a 100 Mbps line, and this is also a 100 Mbps line? Now, which one do you think is the better link? Do you think the slow 64 kbps line is better, or do you think this 100 Mbps line is better? Obviously, this 100 Mbps line is much better, even though it is two hops, right? So RIP, even if this information is given to RIP, RIP doesn't consider this information in their routing decisions. It is going to choose the least hop count, which is 1 in this case. But The other type of routing protocol is link state, and OSPF uses link state, right? It is a link state routing protocol. So what OSPF would do is OSPF would look at the link state, like this is 64, this is 100, and this is 100. OSPF will decide to go through this instead, right? Which is the correct thing to do. So that's why OSPF is a much complicated and much comprehensive routing protocol compared to RIP, which RIP is a very basic routing protocol. Now, both of them have their own advantages and disadvantages. RIP, like I said, is very basic. It's easy to configure. OSPF, a little complicated. You need to understand a lot of factors before we configure that. EIGRP is a Cisco proprietary, or at least it was Cisco proprietary till very recently. Today it is open standard. So EIGRP combined the best of both worlds. So it looked at distance vector and it looked at link state, and it made a routing protocol which took into consideration bandwidth and it took into consider the delay, right? So it took, like for delay, if it's a longer link, it is going to be if it's got more hops, obviously there's going to be more delay. If it looks at the bandwidth, so it knows which is a higher bandwidth link, right? So it looks into both. So if you look at when we do an EIGRP very soon, you will understand what I'm talking about. There is a formula through which it derives their metrics. So bandwidth and delay is part of the formula, right? So that's how it makes its decision. So that's the difference between distance vector and link state, where distance vector looks at only the distance, link state looks at only the link state, like the speed and the bandwidth. Well, EIGRP, which is known as a hybrid routing protocol, and it is called hybrid because it looks at both. It takes a little bit of distance vector and it takes a little bit of link state, right? So hybrid protocol like EIGRP does much better. So from a Cisco perspective, EIGRP is the best routing protocol to use. So all the Cisco engineers would prefer that, because if you look at the next slide, you will see that it has got a better believability. We will talk about that in a while. But OSPF is the most used routing protocol in the world. If it's a non-Cisco environment, OSPF is most sought after because it's an open standard. It's always been an open standard. But EIGRP, recently it has gone open standard. So people are starting to use that because it's a much more advanced routing protocol. So I talked about believability. Now, normally, like in this case, when router A when it gets information about the same route from two different sources, it had a formula through which it makes a decision, and only one of them goes into the routing table, right? That's very easy because it looks at this option, it looks at this option, and it knows what to compare, and it makes a decision, and one of the entry goes here. Of course, OSPF can do load balancing if it's similar cost. So if both of them have exactly the same cost, you can do load balancing. And don't worry about all that. We will come back into load balancing, a little bit of OSPF in our next video. But for this video, understand that load balancing is possible. But leave load balancing for a bit. It makes a decision. Whatever that decision, it makes a decision, and one of the network goes into the routing table. Right? It's easy to make a decision. But consider this. Now you have router A, router B, let's call it A, and this is B, and router C, and this is a company, like it's your company, right? Now let's assume your company acquired another company. This happens, merger and acquisition keep happening in the real world. So let's assume you acquired, or your company acquired another company which has router A1, B1 and C1, and then you have ABC. Let's assume this old company of yours, so this is company 1 and this is your acquired company, and let's assume you have been using EIGRP and your new company that you have acquired uses OSPF. Now, changing something that's happening, there's been like, it's not, I'm not saying it's not possible to change this company over to EIGRP or move your company from EIGRP to OSPF, but it's a lot of administrative headache. right? And then the whole process of change management, and it's a big administrative headache. If the company is big, it's huge. If it's a small company, yes, you can do. There's a better way. You don't really have to do that. You can do something called as redistribution, right? So you could take routes from EIGRP and redistribute to OSPF, and take routes from OSPF and redistribute it to EIGRP. This is possible. How do we do that? One of the router in your network would do both, right? So you would do EIGRP and OSPF, right? So let's assume this router, your B router or router B would do EIGRP and OSPF. So it has a routing table. In the routing table, you will have routes that is denoted learnt by EIGRP. Then you will have some routes learnt by OSPF, right? So you would have both the networks. So if you have unique networks, then there's no problem. You know that, like for instance, in this company, you have some network that is there only in this company, and there's some network that's there in this company. So whatever there in the company on the right would be only on OSPF. Whatever networks that you have on your old network, it's on EIGRP. But for some reason, let's assume there's some type of interconnection. Now you have a particular network that is learned by both. OSPF also has a link to that network, right? There's some network, and EIGRP also has link to that network. Now both of them, your EIGRP routing table also tells, okay, there is this routing table, I've learned it through EIGRP. Now OSPF also says, I have learned this route through my routing protocol. Now you can't compare this apple and orange. There's no way the router can compare between two different routing protocol without having a way to have a believability table. So that's why we have something called as the admin distance. Now admin distance is if it's a directly connected route, right? If this router, you're talking about this network, then it's a connected network, it will have an AD of 0. That's the most believable, right? So if you have somebody, like for instance about this route, if B is directly connected to that, and if A is telling that I have access to this particular route, right? Whatever this route, A is telling he also knows about that through C, right? Obviously, B will say, thank you so much, you're giving me that information, but he's directly connected to me and I believe that more than anybody else, so I don't need your information, right? That's believability. So connected is 0, that's the most believable. Then you have static route. If your administrator has statically configured a route, that's the second most believable. Then EIGRP is 90. It's better than OSPF, which is 110, which is better than RIP, which is 120, right? So if EIGRP and OSPF both advertising the same network, the router will believe EIGRP because EIGRP has got 90, which is more believable. So that is going to be used most of the time, right? So this is what admin distance is. Admin distance is a way to have believability when you're using multiple routing protocols, right? So like I said, this is a brief video. It's more like a precursor. Just wanted to get you all up to date or up to speed with some of the topics, some of the topics that is part of our exam topics on Ccna. Like you know that we are following ICND2, so these are the two exam topics that was there, 2.2 and 2.3. So we have covered that, and next is 2.4. We will get straight into your most sought after topic in our entire, not ICND2 or ICND1, I'm talking about the entire Ccna program that we're running here. This is the most sought after. We have had multiple requests. People have asked, where is our OSPF video, where's EIGRP video? You know what, that is the video that's going to come next week, right? So stay tuned and we'll see you right back. Bye bye.